All right, guys, welcome to your study guide review. I'm going to assume that you have your study guide in front of you, and I'm going to spare kind of reading through the entire problem and just point out some important parts. So the first thing I want to point out is that Jeremy is walking his dog. He steps out. He's out for half of an hour, and the bucket is filled for, is filled 1/5 of the way. So for part A, it's asking what is the unit rate which the water is leaking per hour. So we're looking for unit rate. Okay, so there's two ways we are able to do this problem. So method number one, we can make a table. All right, so we have time, and we're going to compare this to amount. So we know in 30 minutes we can, or we have filled 1/5 of the bucket. So what I want to do now is figure out what I can do in 1 hour, and I know 1 hour is 60 minutes. So in 60 minutes time, I times this by 2 to get 60. So I'm going to times this by 2, and you're going to get a number. So 1/5 times 2/1, and that's going to be your answer in here. Okay, again, I'm just going to guide you. I'm not giving you the solutions. That's one way. Another way, so I'll split my paper down. Another way is to write a ratio of amount compared to time. Okay, and how do I get that? In a half hour, here, what is the rate at which the water is leaking? So the amount of water compared to the time per hour. So water to hour. So amount of water to hour to time. So we were able to collect 1/5 of a bucket of water in 30 minutes of time. So what you can do is take 1/5 and divide it by 30. Okay, so these are two different ways. So this is method one. Most students will like this way the best, and that's completely fine. And this is method two. Most students really won't see it this way because a lot of you don't like having a fraction in a ratio. And that's okay, and don't be afraid of this. It's completely fine. For part B, write an equation that represents the relationship. All right, so all I'm going to tell you is the answer that you get for either method one or method two. That's going to represent your K. So whatever answer you get is going to be your K. So when you divide, whatever your answer is, it's going to be K. So remember, Y is equal to KX. K is going to be changed with whatever answer you get in part A. So it's going to be Y equals whatever your answer was from above, X. Number 3. What is the longest that Jeremy can be away from the house before the bucket is overflown? So a common question I get here is, well, how big's the bucket? Or, all sorts of other questions. But we don't need to know the size of the bucket because they tell us back at the top that after 30 minutes of time, 1/5 of the bucket is full. So a full bucket is filled when this fraction gets to 5/5. One whole bucket reaches the top. So what we're going to do is we're going to make a chart and see how long it takes to fill up 5/5. We need to get out, Dante. So let's make our table. So we have our time. Hi, Dante. Being a little creepy. Please stop. All right, we have our time and we have our amount. Right. So in 30 minutes, we have 1/5 of the bucket full. So what I'm going to continue to do is continue to add 60 minutes here and continue adding 1/5 here. So after another 30 minutes, which is 60 minutes, we have 2/5 of the bucket full. I'm going to add another 30 minutes and go to 90 minutes. I have 3/5 of the bucket full. So you're going to keep going until you get to 5/5, and that'll tell you how long it will take before the bucket overflows. So you want to bring this all the way down to 5/5. So 4/5 and then 5/5. Okay, and then add 30 minutes for each. Okay, so that was number 1, A, B, and C. We're now going to move into number 2. I'm just going to put my phone down a second. All right, don't go anywhere. I'm just switching papers. Here we are. So for number 2, so farmers often plant crops in circular areas because one of the most efficient watering systems for crops provides water in a circular area. Passengers in airplanes often notice a distinct circular pattern as they fly over land used for farming. A photographer takes an aerial photo. An aerial means like from the top down. So it's kind of like standing on a chair, for example, and taking a picture of something below you. Except these people are in an airplane taking pictures of the ground beneath them. So a photographer takes an aerial photo of a field which a circular crop area has been planted. He prints the photos and notes that 2 centimeters in length in the photo corresponds to 100 actual meters. So this represents the drawing, and this here represents the actual. So part A, what is the scale factor of the actual farm to the photo? Okay, what is the scale factor? So what we need to do is we're going to compare 2 centimeters to 100 meters. Okay, and I got these numbers from here. 2 centimeters compares to 100 meters. So what we need to do in order to write a scale factor is make both of these numbers the same unit. So this is in centimeters, this is in meters. So what we're going to have to do is either convert both of these to meters or both of these to centimeters. So I can show you both ways, but all you need to remember is that you're going to do it one way. All right, and over here, if you see this is just my work. So here's a little story to help you convert meters to centimeters or kilometers and so on. So here's a story. King, this stands for kilo. Let me do it this way. Kilo. King Henry died by drinking chocolate milk. So K stands for kilo, H stands for hecto, D stands for deca, B is your basic unit like meters, liters, or grams. D stands for deci, C stands for centi, and M stands for milli, like millimeters or milligrams or milliliters. Okay, so I'm going to convert meters to centimeters. So 2 centimeters over, and I'm going to convert meters to centimeters. So how do we use this table? So meters is here, and I want to go to centimeters here. So I'm going to go from this spot to this spot. So if I'm here, which direction am I moving to go here? So I'm going 1, 2 units to the right. So what that means is I take the decimal in this number. What decimal? Well, if you don't see one, it's at the end. And I move it to the right 2 places. And I'm going to move it 2 places. So I get 2 centimeters over 10,000 centimeters. And I reduce that. I'm going to divide both of these by 2. So 2 divided by 2 is 1 centimeter. And 10,000 divided by 2 is 5,000 centimeters. So my scale factor is 1 to 5,000. So this is the solution I'm looking for. So this is one way to write the scale factor. The other way is to convert both of these numbers to meters. So I'm going to do that over here. So 2 centimeters. And the question I hear all the time is, how do I know which way is the right way? Well, they're both the right way. Either way is okay. So this is going to stay 100 meters. So if I'm here at centimeters, I want to convert to meters. So I'm going to go move my decimal left. 1, 2. So this is probably one of the biggest reasons why we don't convert, because our numerator is going to turn out to be a decimal. So we're going to take this 2. If you don't see a decimal, it's at the end, and we're going to move it left 1, 2 places. So we get 0.02 over 100, and this is in meters. Now there's a rule in math that if we're trying to write a fraction, that these numbers have to be whole numbers each if we're trying to reduce it. So to move this to a whole number, we have to times it by 100 now. So times 100 times 100, we get 2 over, and if I times this by 100, I'm essentially just adding 2 more zeros. So if you notice, it boils down to the same thing. It boils down to 1 over 5,000. So I would recommend just sticking with this method and not so much this. But either way, it gets you to the same thing. Part B. If the dimensions of the entire house are 25 centimeters by 20 centimeters, what are the actual dimensions of the rectangular land in meters captured by this photo? Okay, so notice it says we want the answer in meters. So I know if I go back to the original scale that 2 centimeters is 100 meters. If I reduce that, I know that 1 centimeter divided by 2 is 50 meters. So I'm going to use this and make a table. Scale, actual. And even if you didn't reduce and you just used this, you can still get your answer. It's just going to take an extra step, but it's okay. The solution is going to work out just the same. So 1 centimeters to 50 actual meters. And the question is saying, let's figure out what this 25 centimeters and what this 20 centimeters actually measure. What these numbers actually measure. Okay, so what do I do to 1 to get to 50? Well, hopefully you're saying we are multiplying by 50. So 1 times 50 gets me to 50. So I'm going to take each of these two numbers and do the same thing to get my actual. So I'm going to times this by 50, and I'm going to times this by 50. Okay, so that's part B. flipping through my notes here so we can get through the math pretty quickly. We're going to skip over part C. So you are welcome to skip C and let's hop into the next page. Just give me a second here. All right. Oops. Sorry about that. I forgot my computer at school, and I'm doing this video in my room on my cell phone, and it's definitely a way harder method to do this on the phone than it is on my computer. So here we are. A store is having a sale to celebrate President's Day. Every item in the store advertises 1/5 off the original price. If an item is marked on a sale price of $140, what is the original price? So we know that $140 is the sale price. So first let's start with our tape diagram. So if it's 1/5 off, I'm going to make 5 boxes. So 5 boxes is going to represent the total price. So 1, 2, 3, 4, 5. I know if I am saving this 1/5, I'm saving 1/5. So that means these 4 are the amount that I pay. So I save 1/5, so I'm paying 4/5. So far so good. And I know that these 4 boxes cost me $140. Okay, this is my sale price. Sale price. All right, and I'm also sorry if the writing is off. I'm literally looking through my cell phone as I'm writing. I'm not looking at my paper. Otherwise, I won't know where I am, and it's a bit of a challenge to do. So what I'm going to do to figure out what each of these pieces cost, I'm going to take 140, and I'm just going to divide it. I'm going to divide it by how many boxes do I have. I'm taking 140 and splitting it between 4 boxes. So if you do that in your calculator, you're going to get some number. Okay, it's going to be a nice whole number. So that number is going to represent each box, including this one. So say you get the answer 20. I don't want to give you the solution. I want you to figure it out. So say this number is 20. You're going to put 20, 20, 20, 20, 20. To find the original price, you're going to take this number and multiply it by 5. And that'll give you the answer to the original price. So if this number is 30, we would do 30, 30, 30, 30. And it means you saved 30. So to find the original, you would take 30 times 5, and that 150 would be the original. But again, I don't want to tell you this number because I want you to figure it out. So whatever this number is, put it in here and multiply it by 5 because we have 5 boxes that each represent this number. All right. If you have questions, bring them to school Monday and I'll be happy to help. Okay. Number 4, this is a fun one. All right, the picture, when I first looked at this, the picture is way more involved than it ought to be. So don't let the picture confuse you. It's way more than what you need. So over break, your uncle and aunt ask you to help them cement the foundation. The foundation's like the cement part that you kind of find like in your basement or the very bottom part of your house that's like attached to the dirt or the land of their newly purchased land, and gave you a top view. So if you were standing, like if you were looking at their house with no roof at the top and you're looking down into an open house, like this is what it would generally look like. I know, it's way too much information. I gave you top view, blueprint. A blueprint is just a map. Pretty much this is a blueprint of the area and proposed layout. A small legend on the corner states that 4 inches corresponds to 52 actual feet. So that's our scale. Oops. 4 inches to 52 feet. Okay, part A says, what is the scale factor? This is a very similar question compared to, I think, what we did in number 2. So let's begin. Okay, this is what I did. 4 inches to 52 feet. So what I did was I took both of these numbers to make it easy, and I divided them by 4. So if I divide by 4, 4 divided by 4 gives me 1 inch. So 1 inch, if I divide this by 4, I get 13 feet. This is what we call the unit rate. Now what I want to do is find a scale factor. Remember, scale factor, both numbers have to be in the same unit. So I know, so let's go over here. This is my brain. I know that 12 inches equals to 1 foot. So if I have 13 of these, I have 13 groups of these, what I'm going to do is convert feet to inches. So for every one of these, there's 12 inches. So if I have 13 of these, every one of those has 12 inches. So I'm going to multiply this number by 12. So 1 inch is 2. 13 times 12, where's my answer, is 156 inches. This is the scale factor. So my final solution for this problem is, I'll write it right over here, 1, oops, sorry, papers are falling. 1 over 156. This is my final answer. Okay, so that was 1A. Okay, for 1B. 1B, if the dimensions of the foundation on the blueprint are 11 inches by 13 inches, what are the actual dimensions in feet? So this will tell you whether you need the scale or the scale factor. So what I want to use here is my scale. I want to compare inches to feet. And we learned at the beginning of this problem that 4 inches, I'm going to go back to part A here in my work. We know that 4 inches represented 52 feet. So if I reduce this, you can use either one of these, that 1 inch is 13 feet. So I'm going to use this because it's already my unit rate. So let's begin. So I know 1 inch in my drawing or my scale represents what did we say here? 13 feet in my actual or my original. Okay, we've been using both words in class. And just as a friendly reminder, this represents your X, this represents your Y. Okay, when we divide Y by X, that gives us K. So if I take 13 divided by 1, my unit rate is 13. Okay, so let's see, what are we converting again? We have the foundation in the blueprint is 11 inches by 13 inches. So I know that these numbers go here because these are the drawing numbers. These are the numbers that represent the blueprint. The blueprint is not the real house. It's, oh, my paper's over there. It represents that picture that we were looking at on the previous page. So these are the numbers that represent the length and width in the picture. And we want to know what is the actual So the question's even telling you we are looking for these actual numbers. Therefore, these numbers represent the drawing numbers. So if I take 13 and divide it by 13 to get 1, when I go from this side to this side, I divide by 13. So when I go from x to y, I multiply by 13. Multiply by 13. So take your calculators and do 11 inches times 13 and do 13 times 13. And we should get an answer. Hopefully you have one by now. We get 143 feet by 169 feet. Unfortunately, I can't show you C without showing you B. It's the only reason why I gave you those answers. Otherwise, I would have left you hanging, left you to do the rest. So let's do part C. Dante's on his way up again, so get ready. So part C, you are asked to buy bags of dry cement, and you know that one bag covers this total square feet. So when you have square feet, these numbers represent area. Wow. So if this is my foundation, remember area equals length times width. So what they're saying is it covers a small part of this area. How many bags would you need to buy to finish this project? So the first thing I need to do is find the actual area. To do that, I'm going to take the actual length, 143, times it by the width, which is 169. And that gives me a total area of 24,167 feet squared.
200 million.
Say hi.
Hi.
Okay, and the second thing we want to do is real simple. So if I know that this is the total area I want to cover, please stop. And this is how much one bag covers. I'm just going to take those two numbers and divide them. Okay, and when I divide these numbers, I get an answer of 69.04. But since we have a remainder, 69 bags won't cover the whole thing. There's going to be a little tiny bit left over. So you will need 70 bags. Unfortunately, most of that 70th bag will be left over, but you're going to need a tiny, tiny bit to cover this 4/100ths of space. So take your total area, 14,167, and then divide it by how much area one bag covers. All right, let's take a look at part D. All right, I am going to end this video here, and I'm going to start a new one to do the remainder of the packet.